A thyristor is a 4-layer semiconductor device consisting of alternating P-type and N-type materials, PN-PN. A thyristor usually has 3 electrodes, an anode, a cathode, and a gate, also known as a control electrode. The most common type of thyristor is the silicon controlled rectifier, SCR. Thyristors are mainly used where high currents and voltages are involved and are often used to control alternating currents, where the change of polarity of the current causes the device to switch off automatically, referred to as zero-cross operation. A thyristor with a PN-PN structure has 3 junctions, PN, NP, and PN. If the anode is a positive terminal with respect to the cathode, the outer junctions PN and PN are forward biased, while the center NP junction is reverse biased. Therefore, the NP junction blocks the flow of a positive current from the anode to cathode. The thyristor is said to be in a forward blocking state. Similarly, the flow of a negative current is blocked by the outer PN junctions. The thyristor is in a reverse blocking state. Another state a thyristor can exist in is the forward conducting state, whereby it reverses a sufficient signal to switch on and it starts conducting. Let's take a minute to highlight the unique properties thyristor bring to a circuit by going further into the nature of the signal. The common thyristor solution used in higher current AC switching is 2 isolated SCRs. The added hardware and packaging required to provide the needed isolated heat sinking in this configuration is a cost drawback. Trikes allow a single heatsink but are limited by their thermal performance in current, blocking voltage, and higher frequency application. The micro-semi AGT anode gate thyristor device is a thyristor providing the reverse electrical switching of the SCR on a common mounting plane. The AGT effective mirrors the operation of a matching SCR in the positive polarity by switching in quadrant 3. Thyristors are mainly used where high currents and voltages are involved and are often used to control alternating currents, where the change of polarity of the current causes the device to switch off automatically, referred to as zero-cross operation. The device can be said to operate synchronously, being that once the device is triggered, it conducts current in phase with the voltage applied over its cathode to anode junction with no further gate modulation being required. The device is biased fully on. This is not to be confused with asymmetrical operation, as the output is unidirectional, flowing only from cathode to anode, and so is asymmetrical in nature.
Hello, my name is Muhammad Azrin, S61928. For the introduction, IGBT is the IGBT or insulated gate bipolar transistor is the combination of BJT and MOSFET. Insulated gate refer to the input part of MOSFET having very high input impedance. It do not draw any input current, rather it operates on the voltage at its gate terminal. Bipolar refer to the output part of the BJT having bipolar nature, where the current flow is do not both type of charge current. It alone it to handle very large current and voltage using small voltage signal. The hybrid combination made the IGBT a voltage control device. For the internal structure of IGBT, IGBT can be structure which the equivalent current that consists of two transistors and MOSFET. As the IGBT processes the output of the Boolean combination of the PNP transistor and PN transistor and MOSFET. IGBT combine the lower saturation voltage of a transistor with the high input impedance and switching speed of a MOSFET. The outcome obtained from the combination deliver the output switching and conduction characteristic of the bipolar transistor, but the voltage is controlled like a MOSFET. Part of the transistor. T has three terminals: first gate, collector, and emitter. The terminal name also implies be taken from both transistors. Gate terminal, as it is the input path, take from MOSFET, with the collector and emitter as they are the output. They take from the BGT. For the function IGBT, the most basic function of an IGBT is the fastest possible switch of electric current, thus achieving the lowest possible switch loss. As the name insulate bipolar transistor, however, an IGBT is bipolar transistor with an isolated gate structure. The gate itself is basically an MOSFET. What is the use of IGBT? IGBT are widely used as switching device in the inverter current, for DC to AC conversion, for driving small to large motor. IGBT for inverter application are used in home appliances such as air conditioning and refrigerator, industry motor, and automotive main motor collector to improve the efficiency. There are some advantages of using IGBT, and when talk about it, there would be some con or disadvantage in using it. As of the advantage of IGBT, it has higher voltage and current handling capability. It has very higher input impedance. It can switch very higher current using very low voltage. It is voltage controlled. It has no input current and low input. Move to the disadvantage of IGBT. It has a low switching speed, the MOSFET. It is unidirectional. It cannot conduct the reverse. It cannot block higher reverse voltage. It is constantly that BJT and MOSFET. So, what is the application for this IGBT? What did it apply? The answer to this equation. It is used in SMPS to supply power to sensitive medical equipment and computer. It is used in UPS system. It is used in AC and DC motor drive, offering speed control, and it is used a chopper and inverter. So that's all from me today, talk about IGBT. Thank you.
Assalamualaikum and hi, my name is Nur Aliana Alisa binti Ahmad, numbermetry S64257. I will present about IC, analog and digital. Introduction. An integrated circuit is a minuscule chip made of semiconductor material. This chip is what makes the entire circuit. It is quite small in comparison to the basic circuit. Circuits made of different components and approximately the size of a human fingernail. At present, the most common integrated circuit used are the monolithic chips. Integrated circuits meaning would be a chip used in almost every electric equipment or appliance found in the present times. This includes computer, television, mobiles, and even toys meant to be used by children. Difference between IC analog and IC digital. Analog IC. This IC works over a constant signal range and are subdivided into RFICs or radio frequency integrated circuit and linear ICs. The relation between the current and the voltage might be nonlinear in the majority of the cases over long signal range. The most frequently utilized analog integrated circuits are the operational amplifier or on-ramp, which are quite the same as differential amplifiers. These come with high voltage gain and fewer transistors in comparison to the digital integrated circuit. Digital IC. These are IC chips that work only a few levels that are specially defined instead of working on all signal amplitude levels. The digital integrated circuits are specially designed using several digital logic flip-flop, multipliers gate, and other electrical elements of circuit. The logic gates operate with digital input and binary input data like 0 and 1. The digital integrated ICs are widely used in microprocessors, computers, computer networks, frequency counters, and digital signal processors. In this category, you can find other subcategories like programmable ICs, logic OCs, memory chips, interface ICs, and power management integrated circuits. Application of integrated circuits. Integrated circuits are used in different forms, which is burst washers, radar, computers, juice makers, televisions, calculator chips, counters, timer, memory chips, temperature sensor, flip-flop, logic device, video processors, and so on. That's all from me. Next, to other presenter. Thank you.
The majority of modern integrated circuits, commonly referred to as chips or microchips, employ a complementary metal oxide semiconductor (CMOS) as their semiconductor technology. Metal oxide semiconductor field effect transistor (MOSFET) technology is the foundation for CMOS transistor. Depending on the voltage supply, MOSFET actually as switches or amplifiers to control the quantity of electricity flowing between the source and drain's terminal. Doping is term used to describe the addition of impurities to a material, such as silicon. To adjust conductivity, different level of semiconductor doping can be used. However, other elements such as the kind of contaminator used can also affect conductivity. The positively charged p-type semiconductor transport current as hole in the absence of electron. A hole has a positive charge that is opposite and equal to that of an electron. In the opposite direction from the holes, the electron move. There is a negative charge on the n-type semiconductor. In this instance, negatively charged electron current is carried by the semiconductor. We move off the function of CMOS. Your laptop BIOS firmware, which is in charge of starting up your computer and configuring data flow, is powered by the CMOS battery. If your laptop have trouble starting up, if drivers disappear, or if the date and time on your laptop are off, your CMOS battery may have died. The BIOS firmware in your laptop is powered by the CMOS battery. Even when your computer is not plugged into a power source, BIOS must continue to the function. The battery enters the picture here. The CMOS battery supply power to BIOS when your computer is unplugged. Both laptop and desktop computers use CMOS battery. Although laptops use them more frequently, that because desktop computers are frequently left unplugged for a shorter period of time than laptop. The majority of desktop computers are rarely removed from their power source. Every time your laptop is plugged in, the CMOS battery is charged. The battery only loses charge when your laptop is unplugged. From the date of manufacture, the majority of batteries have a lifespan of 2 to 10 years. Your battery will last longer the more often you left your laptop plugged in. The example of commercial RF CMOS chip include Intel's DEC cordless phones and 802.11 Wi-Fi chips created by Antares and other companies. Commercial RF CMOS products are also used for Bluetooth and wireless LAN (WLAN) network.